Counting formulas, part 2. When you have some elements in a set that are identical, there's no way to tell them apart, but you need to know how many different ways it's possible to pull them out, or to put them in different orders. For instance, suppose you've got a bag with 7 marbles. 3 of them are red, 2 of them are yellow, 2 of them are blue, and you can't tell these colors, and you can't tell the marbles that are the same color apart. So that red 1, yellow 1, blue 2, yellow 2, red 2, red 3, and blue 1 is going to look to us exactly the same way as the third red one times the second yellow one, and so on. It still consists of a red, yellow, blue, yellow, red, red, blue combination. So we have to have the ones that are going to look the same counted out so that they're all counted as just one, because we have no way to tell them apart. And yet a red, yellow, blue and a red, blue, yellow is still going to be different, so order matters. So let's look at it this way. If we have 7 marbles, so that there are 1, 2, 3, 4, 5, 6, 7 positions to fill, this is going to be 7 factorial possible ways to actually pull them out. But since we can't tell the red ones apart, we're going to have to reduce this number so that all 3 of the red ones only count as 1 red one, but of course there's going to be 3 times that comes out. So basically we do it by taking the factorial of how many there are of each color and dividing that part out. So it's going to be 3 factorial, 2 factorial, 2 factorial on the bottom. So in the calculator, I'll go ahead and do this piece by piece. 7 factorial is 5040, but we divide it out as 6. 3 factorial is 6, 2 factorial is 2, twice. So we're going to end up with 5040 divided by 24, reduces it actually down to 210 possible combinations. So the formula to do a permutation where order does matter, but where some of the elements are identical, is going to be the total number of elements, but factorial, but divided by each of the factorials of the matching elements, however many there may be. Now, when order doesn't matter at all, that's when we're talking about what they call it a combination instead of a permutation. In a combination, order does not matter. So this is where all the elements are of equal status. AB and BA are going to be counted as just one. So we have to take the possible number of ways to do this overall. Same thing you'd get if you were doing a factorial, but divide out not only for the permutation, the n minus r factorial, just in case we don't pull all of them out, and this time divide out by r factorial. We would write this as NCR. Remember, with the permutation, the symbol can be NPR, or you may see it written as CNR. It means we're going to choose R elements out of N. And sometimes they look at this, they put combination, mix it with the word committee. Let's say you're going to choose 3 people from a group of 10. How many ways are there to do it? In this case, the 3 people are going to be a committee, not president, vice president, and secretary. So John, Joe, and Sue are the same as Sue, Joe, and John. It's just any 3 people. So we've got the 10 factorial. If we were going to choose all 10 to put them in order, then it would be 10 factorial. However, we're going to do the 10 factorial, but just take the first 3 people from each possible listing of the 10 people. So it doesn't matter if the last 7 are put in a different order. So we're going to knock those out. So it's going to be 10 minus 3 factorial. And because Sue, Joe, and John, Joe, and Sue are going to create the same group, we have to also divide out the number of ways that those 3 specific people can be chosen. So that's going to be 3 factorial. Now you should have this on your calculator. Look for these notations. On the TI-30XS, the NCR is the second function over the 8. So I have to hit the second function and 8. So if I want to real quickly figure out what 10 choose 3 is and just use my calculator, I have to turn it on. Hit 10. I would personally, on my calculator, hit the second function and then the 8, which is the NCR button, like using the shift. Then I would hit the 3 and then equals. And it immediately spits out 120. Now notice that the 10P3, the permutation where you can choose 3 out of 10 people, is going to be a much larger number. I use the second function in the 9 to get the permutation. That turns out to be 720. Now, if you absolutely can't find this on your calculator, or if you've only got a calculator that does nothing but add, subtract, multiply, and divide, let's see how you would actually do this in StatCrunch. For instance, on this problem, when testing for a current in a cable with 12 color-coded wires, the author used a meter to test 2 wires at a time. How many different tests are required for every possible pairing of 2 wires? This is asking us, how many ways can you choose 2 at a time out of 12 possibilities? There's no option here to pull up StatCrunch, but when you click on Question Help, StatCrunch is going to come up here. We want to go to Data, come down here to Compute, Expression. We're going to Build. Now you see all these functions over here? These functions include fact, that's your factorial. Exponent creates an exponent. So if you want to do something to a ridiculous exponent, you can use that. We've got perm for permutation. We've got comb, short for combination. Now in this case, if you're going to test 2 wires, does it matter which one you chose first? No, order does not matter in this case. So we're going to do a combination. We want to add the function. It puts it up here. Notice that there are parentheses with a comma in the middle. So we want to do a combination of 12, choose 2. So I don't have to use the buttons over here. I can type it on the calculator. 12, and then I'm going to move over with my cursor, choose 2. I'm just going to hit OK. I'm going to hit compute. It's 66. There's 66 ways that you can choose 2 wires at a time out of 12 when order does not matter. How would I have done this in the case of a permutation where it mattered? Go to Data, Compute, Expression, Build, choose your function. In this case, if I wanted a permutation, I would come down here to Permutation, Add Function. It gives me my function with the parentheses and the comma. So if I wanted to do 12, choose 2, what would be the difference? Okay, compute. If order had mattered, there would have been 132 ways to do it. What if I just wanted the factorial? Data, compute, expression, build. Now I want to find my factorial. Now factorial only operates on one, add the function. Factorial only operates on one number, right? So if I was going to do this by hand and I wanted to do the factorial of 12 divided by the factorial of 12 minus 2, which would be 10, I would go ahead and do it this way, but I can do this. I would do my 12. Make sure you put your numbers in. Okay. Compute. The factorial for 12 is 4.79 approximately times 10 to the 8th power. This is in scientific notation. Your calculator will do this also. It has, remember your scientific notation, you've got your first number between 1 and 10, at least 1 smaller than 10, times 10 raised to the whatever the exponent is 8. So that's a really, really, really big number. That's how you do it in StatCrunch. All right. There isn't any way to use StatCrunch with just one punch to do the one where you have permutations with some identical elements. So in a case like that, you're going to have to actually do the factorials. Now, I really think it's probably better to just do this on your calculator. You're going to have your calculator for a long, long time, well after this class is over, unless you want to pay for a subscription to StatCrunch. Your StatCrunch access will end when this class ends. However, just in case you ever have to do any of this again for fun and entertainment, then I would suggest you go ahead and do it on your calculator. We'll see you later. Take care.